Dear civil engineers, welcome back to School of Civil Engineering. In this lecture, I am just going to show you that how we'll design a pile cap using CSI SAFE 2020. So to do that, first of all, we'll go here, new model, and from here I'll go here, and you have to select display unit. So I'm using US customary, and as I'm designing pile cap, so this is a concrete element, that's why only concrete design codes are required, so that value are not required actually. So from here I'm selecting ACI 31819 and okay. So here you have to do one thing actually. What is the issue actually? So I'll use a Excel sheet here. So this is a Excel sheet I have collected from internet, and you'll get that download link. Okay, so I have downloaded that Excel sheet from civilmdc.com. Now first of all, I have to provide here the column width and depth. So I'm providing here column width and column depth here. So I'm taking 15-inch and 18-inch column size, and the river properties that is 500 megapascal, and concrete properties I'm considering my concrete properties are 25 or 28 or 27. Okay, so almost 27.5, that means 4000 psi or 4 ksi, 27.5 megapascal. And here the modulus of elasticity have calculated automatically, and we know the modulus of elasticity of steel bar are 2 lakhs megapascal. And after that you have to provide here the pile data. Okay, so what is the pile diameter? I am considering a 20-inch pile, that means 0.0581 meter. And again, safe load of pile capacity. So what will be the safe load of pile capacity? Actually, what is the value of that? If you pile, how much its capacity actually is bearing load bearing capacity of pile. So I'm considering here its load bearing capacity of our pile are 866 kilonewton. Okay, and here 194.7 keep the pile capacity. Now number of length of pile. So here I have considered my pile length are 16 feet. Okay, 16 feet are my pile length, and after that the loading or loaded data. So I'm considering only the vertical force acting on my pile cap. So what will be the value actually? I am considering here my value will be 2000. Okay, 2000 kilonewton. That means 449.6 kip. That means 450 kip. Okay, total applied load, and it's okay. Now everything have calculated. Now if I just go here, just see here the number of pile. Okay, the number of pile are required number of pile are 2.7. So here I'll consider okay 2.7. So I'll consider for 3 pile. If I consider use total number of pile, if I consider total number of pile 3. Okay, so here 3, or if I consider total number of pile actually 4. Okay, so if I consider total number of pile 4, then we need the number of pile on each row 2 and 2. So I'm considering total number of pile 4. Okay, and now here you can see the size of pile. So total length of pile 2.5 meter, and here also 2.5 and 2.5 meter or 2.54 meter. So as I'm using that value actually, if I just increase that size little bit, let's see 2.54 meter, and here this is 100 inch, and also in that side 100 inch. That means I need a pile cap with area 100 feet, 100 inch by 100 inch. Here I'm going to take that value. Number of grid in x direction, I'll consider 2. Number of grid in y direction, that is also 2. And what will be the value of that? 100 inch, that means divided by 12, 8.33 feet. So same, 100 inch divided by 12. So this is my data, and no need to worry about the data. After that, I'll take grid only, and simply I'll click here OK. So when this is done, now see here, this is the actually total area for our pile cap. When it's done, after that I'll go here, define, then materials property, and from here I'm considering my concrete are 4000 psi. Just see here, so this is all data are available here for 4000 psi. If you need to change that, I'm requesting you, please watch your previous lecture. I'm related previous lecture of CSI SAFE full playlist, that link are given in description. After that, when that materials is okay, after that I'll go for 500 here. I'll go for the 500 megapascal steel, or I can consider 420, okay, 420 megapascal. So that is 60 ksi. So here, if I go for 60 ksi, now see here, steel are already provided as per ASTM 615 grade 60. If I go here for modify, that all data are available. Now if you need to change that, again I'm requesting you watch our previous lecture, please. Already have shown that how we are able to change the data. Now I'll go for OK. Again I'll go for section properties, then only I need here slab section, and from slab section I'll delete that on, and I'll add new properties. First of all, I'll add pile cap, so I'll give here PC, okay, or pile cap, and here the slab materials property 4000 psi. What will be that? So for our pile cap, we'll consider mat, and initially I will consider a 15-inch thickness pile cap, so 15 inch. Then go for OK, and I'll delete that on, and I'll take copy of it. That copy of property I'll give here pile. After pile cap, we need pile, so everything will be same, okay, and the thickness of pile and pile cap, everything will be same actually, pile and pile cap. Now what we need, again I'll take a copy of that properties. So I need column is stiff, right? So from here I'll select stiff, and the value of 15, that will be same. Then OK, then OK. After that, I'll go for that data spring properties, the most important data. So for pile, we used to provide point spring. I'll click here, I'll add new properties, and point spring PSPR. So what will be that value actually? From here I'll take compression only, and here what will be the value of that? So here I have to take that value, keep per inch. So if I just go to our Excel and see here, that value are available, spring constant or point spring. So value of that will be actually, what is the equation of it? Here K equal to EI divided by L. E means modulus of elasticity of concrete, A area of the pile section, and L the length of the pile. See, if I consider all of that value, I will get that value, and here 1783.5 kip per inch. So 1783.5 kip per inch. After that I'll go for OK. So this data is OK also, then OK. After that I'll go define. Now I'll go load pattern. So here dead load and live load already defined, so I'll only define the two loads. Okay, I'll only design for service load. If you need to add more load, then you can add from here by clicking add new load, then click OK. Then go here for load combination, only I'll take on combo dead load 1, and for live load 1 scale factor, combo 1, then I'll go for 1. Done, everything is okay. Okay, our every data that are required to design pile cap are okay. Now I'll go for modeling our pile cap. So first of all I'll select rectangular section, and from here I'll take our pile cap, and from here I'll draw our pile cap first. Now I'll escape, and first of all I'll go here to draw our piles. So spacing at each of footing 0.5 odd, that means 20 inch. Okay, from side of that pile, I mean the distance between side of that pile to the center of the side pile, it's 20 inch. So I'll go for 20 inch, and each spacing between each pile are 16 inch, and in that side are also for 16 inch. So the spacing is 20 inch from each. I'll go for here and draw joint object, and from here in X direction I need 20 inch, and Y direction also 20 inch for that point. If I just click here, and again I'll go for minus X direction for that point, and for that point I need here, that means this is the opposite of X and opposite of Y. So also I'll give here minus 20, and I'll click here, and for here I need the direction of X and opposite direction of Y, so the X will be plus. Done. Now if I just go for, if I click here, or if I go here view, refresh windows, just see the points are available here. After that I need another point. Okay, I need another point. So actually our 4 piles we have, I mean the point for our 4 piles we have taken. Now I need another point. I need another point at middle of it. So what is the distance between one pile to another pile? That was 60, right? So 60, what will be the middle of that? That will be 30, direction 130 here, see, and here also direction another direction, that is also 30 inch. So I'll get our middle point for X 30 and for Y 30, and if I click here, and if I again click here, just see this is our middle point. Now I'll go here, draw quick area around the point, and I'll take pile, and what will be our pile size? So what is the size of I mean shape of your object? That is circular. And what was our pile diameter? That is 20 inch, right? I'll click here, and I'll click here, 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 and here again, and I'll go for another thing, that is our column stiff, and the size is rectangular, and in X direction that was 20, or I'll just again recheck 18 and 15, so that was 18 inch, and in Y direction that was 15 inch. I'll click here, just see also we have provided our column object. Now I'll select that 4 point, I'll select that 4 point to provide our pile capacity or pile spring property. After selecting that 4 point, go assign, then go to here for shell. Okay, so actually this is not shell. From here you can go for shell, otherwise from here, okay, from frame also you can go for another thing, and for joint, if you go for joint you can go for spring. So as we need the point spring data, I'll go for spring, and from here point spring data, then apply. You see, we have provided our point spring data, then click OK. After that, I'll select that point and I'll assign load on it. I'll go assign, then join load, then force, and here the most important thing, you have to provide that data, the punching shear, I mean size of load of for punching shear. So that will be same as your column. So for X that was 18 and for Y that was 15. After that, I'll select dead load, and for global Z direction, I'll consider my load will be minus, suppose my provided load will be minus, here actually I'll go here. What is the total load actually? My total load 450 kips almost. So I'll provide minus 250 as a dead load. I'll click apply. I'll click here pre-select, and I'll provide 200 for live load, then apply, then okay. So when everything is okay, now I'll go here to check. Just see here, all of our load available here, our spring value are also visible. I'll go for plan view. Now I'll go for run analysis, and before that I'll save. I'm just giving a random name, then I'll save it, and I'll go for analysis. I'll click OK. I'll ignore that, not issue actually. I'll close that. Actually, the steps of arrangement are showing because of my graphics issue actually. So when it's done, now I'll go for punching shear check. Now I'll go display, show punching shear design. Just see here, the value of punching shear design are 1.245. so the every value are more than 1. So I have to change our thickness, I mean pile cap thickness. Now another things I'll check here, go, then for load combo and combo 1 for jet, show only for jet, I'll go for 3D view and I'll apply. Okay, here this is our sorry, I'll just actually this is the value here. You can see here one value, another here, and here and here. That are the value of our pile. I mean applied it, that means applied it load of our pile actually. Okay, so here fz and the another value of fz, that is 150. If I just go here, what was the safe load capacity? 194. So these value are less than our provided value. It's safe actually. Okay, it's safe, but it's absolutely safe, but I have to check for our punching shear again. So for that I'll unlock and I'll go for define our section properties, then slab, and I'll increase that size actually. I'll go for 24 directly, then for pile cap I'll go for 24. You can actually, it is the best process to increase that thickness randomly, I mean 3 inch per times. So it is 20, 24, and for that also 24. Okay, then I'll go for analysis. Done. Close. Now I'll go for here display punching value. So just see these value are also not okay. So it's showing 126 and here 1.49. Every value and the values are not okay. Again I'll close and I'll increase the slab thickness again. So pile cap, for pile cap I'll go for directly 36 because it will save my time. 36 inch, and again I'll go for 36 inch, and again I'll go for 36 inch. Okay, then okay, now reanalysis. Okay, and go here display show punching shear value. This is almost okay. So 1.09, 1.08, 1.08, 1.08. So if I increase our slab thickness little bit, then our punching shear will be okay. So I'll not increase anymore, just you have to increase like that, and your value, this value should be less than 0.9. Now I'll go here plan view and I'll go for design. So display show slab design, and from here I'll go for finite element based design. This is the best process to design. Then I'll go for apply. Now just see here, we can see our required value, and if I just click here, the maximum value is 1.09 for top, and here for minimum 0, and I'll go for bottom apply. Just see here, we're seeing our required value here actually for bottom, and for that one if I click here, just see here we're seeing our required value, and here also no need of reinforcement, here also here. Again I'll go here apply. So see here it's also okay. Now I'll go for that option uniform reinforcing bar system, and I'll also apply impose reinforcement, minimum reinforcement, and for number I'll go for number 6 bar, and also I'll go for number 6 bar, and I'll take a spacing for 6 inch and for 6 inch and apply. You see everywhere this is okay except that middle zone. So I'll go for as this is for bottom, so I'll change for bottom reinforcement to 4 inch center to center spacing. So this is also okay, and if I just go for 7 number bar, then it's also can we need here little bit reinforcement, so we can neglect that. In this way, for every portion, I mean for every direction, you have to design and you have to go for final process. So this is the total procedure to design a pile cap perfectly. So thank you very much, and if you think that is helpful for you, please don't forget to subscribe to our channel and also press the bell icon so that you get every update ever fast. And the most important thing, if you want to support us, please join as a member by clicking the link given in description, and also give us super like. Thank you very much.